By the way, some of you may have noticed that we're in Chapter 10 and we went right past Chapter 9, and that's on purpose. We always do Chapter 9 last, at least I do, because Chapter 9 involves graphing, and Algebra 1 does a ton with graphing, so that if perchance I ever am not able to cover the whole book, the thing that I leave is the thing that gets covered in very minute detail in Algebra 1. So that's the reason. More than likely we'll get to it though, and we will cover it. All right, so 10.2 is plotting data. It used to be that our pre-algebra course did not cover the first kind of data plot that we're going to look at. Now they do, and I always enjoy these. So A is a box and whisker plot. A box and whisker plot. Raph, do you have a question? You're good? Okay. So a box and whisker plot. And it's important that you understand what it represents and how to read the data. Now, our world today is data-driven, way more so than ever before, and it's amazing the data that is out there. And, you know, data is actually power today, and data allows companies to target individuals for sales, and all kinds of things involve data. It's important to display concepts of data. And there are a lot of different devices you can use to display data. No doubt when you guys did science fair, some of you made charts in your science fair, yes? What kind of charts did you use? Anybody remember the kind of idea of what the name of the chart was? Anybody? For example, and you would have learned this already, did you use a bar graph? How many of you use bar graphs in your data? Okay, have the bars, okay. How about broken line graphs or line graphs? Okay. How about pie graphs or pie charts? Anybody use those in their data? Okay. There are a lot of different ways. Scatter plots are mentioned in this chapter. We're going to look at box and whisker plots. We're going to look at stem and leaf plots. We're going to look at histograms in this chapter. There are a lot of different ways to display data. And here's the key. To be able to read all of the different ways to display data is very important. So that if in a situation you encounter a certain kind of display of data, you'll understand what that display represents. Also, if you ever get in the position where you are going to present data, it's important to know the different kinds of ways of displaying data, because certain data displays better in certain situations. There's a certain time when you want to use a box and whisker plot. There's a certain time when you want to use a bar graph. There's a certain situation when you'd want to use a pie chart or pie graph. And so learning these things is part of what we want to begin to learn here in Chapter 10, as well as definitely be able to interpret the data of all these things. So the first one is a box and whisker plot. I always enjoy the box and whisker plot. And so you can see we've got an example there. These are used to illustrate the data divided into quarters. And that's key. Quarters. The data is divided into quarters. Now, don't do this on your notes because we're going to explain some things in a moment. But I just want to show you the quarters. Right there is the first quarter. Right? Again, don't do this in your notes because you'll make a mess. There is the second quarter. There is the third quarter. And there is the fourth quarter. By the way, some of you wonder why you don't always understand what's going on. It's because you're not even looking up at the screen right now. Henceforth, I'm just saying a bunch of words and you're not even looking. All right, but those are the quarters. The box and whisker plot divides the data into quarters. And that's important that we understand that term. All right, we need to go through and name the parts of this box and whisker plot. The first, as you move left to right, the first thing you encounter is the left whisker. You can see the green box in the middle, and then you have a left whisker and a right whisker. A right whisker. Say that 30 times fast. Hence the name box and whisker plot. You have two outside whiskers and the middle box and whisker plot. The lower or left-hand whisker is called the lower extreme, and you need to write that in and name that. The lower extreme. So in this representation, the lowest piece of data is a 50, right? That's the lowest piece of data. Well, if the left whisker was the lower extreme, the right whisker must be called the lower extreme and upper extreme. So you got a lower extreme, you have an upper extreme. Now, you also have some terms, use my green here. You got the line that is the left-hand side of the box. And it ends the first quarter of data, correct? It ends the first quarter of data. It's called Q sub 1, that's Q with a 1 subscript, and it's called the first quartile. The first quartile. As we'll see in a moment, and we'll get down to this a little bit later, it's also called the lower quartile. So what do you think this letter is? Q sub, or this line is Q sub 2, which of course is the second quartile. And of course the right-hand side of the box is Q sub 3, or the third quartile. If you wanted to say so, we usually don't. The upper extreme would really be Q sub 4, or the end of the fourth quartile. Okay. It's just a means of breaking the data up into quarters, and that's what we're after here. We want to see the data broken up in quarters. When do you use a box and whisker plot? When you want to break up the data into quarters. You want to group data. You want to break it up into quarters. That's when you use this type of a data display. Okay, real important, Q sub 2, which is this blue line in the box. Does that blue line look like it's in the middle of the box? No, and it may not be in the middle of the box. It'll always be in the box, but it may not necessarily be in the middle of the box, and most times it's not in the middle of the box. It is, however, the middle piece of data. And because it is the middle piece of data, it is the, what do we call the middle piece of data? The median. You better start learning your terms. That's what we learned on Friday, and that's what some of your homework was about. The median. All right? That is the middle piece of data. The line of the box is the middle piece of data, and therefore it is the median. So we know in this set of data, the median was 80. Okay? I know this. 25%, 1/4 of the data was between 50 and 70. Another 25% of data was between 70 and 80. Another 25% of data was between 80 and 85. And the last 25% of data was between 85 and, I'm calling that like 98. Got to guess a little in this scale. How do I know that? Because remember, a box and whisker plot breaks up the data into quarters. So what percent of data is going to be greater than 70? percent of data is greater than 70? Can anybody answer that question for me? Chloe? Exactly, 75%. Because look, I'll do it here for you on the screen. This part is 25% of the data. There's the 70. So 25%, 25%, and 25%, 75% of the data is greater than 70. You follow? And that's the way box and whisker plots go. All right, so I got another one down here for you. So if you look at that one, if I told you what is the median, you'd have to guesstimate a little bit. So I want you to get an idea in your mind of what the median is, and on 3, I want you to give me that value. All right? So figure out what you think you want to call the median, and on 3, give me that value. Here we go. 1, 2, 3. 42 sounds good. I don't think you'd want to go 43 if you look really carefully. It's definitely not more than halfway between 40 and 45. 42 sounds very reasonable. That is the median of the data. Now, notice on this one, instead of having lines for whiskers, we have dots for whiskers. Is that going to bother you? Hey, some people like to make their box and whisker with lines as the whiskers, and some like to use dots as the whiskers. All right, doesn't matter. The lower extreme is still what value? Lower extreme is 20, the left whisker. The upper extreme is, what's the highest piece of data for this set of data? 55, right? So what in the world is this asterisk doing down here? Well, the asterisk is used when there's one piece of data that doesn't fit with all the other data. All the other data is grouped way up here between 20 and 25. And then we got this one piece of data at a negative 10. It just doesn't fit. And it doesn't make sense. There's a mathematical formula to determine whether or not something doesn't fit. And it doesn't fit with the rest of the data. Now, you've heard this word before. People have used it in conversation. Occasionally, if you'll watch the news people will use this word to say something that doesn't fit the norm. It's out of the normal. It's not normal. Anybody know what it's called? Colby? Abnormal is a word, but it's not the term that we use here statistically. Kristen? The outlier? It is an outlier. Now, again, you've heard that word before. You just didn't know what it meant. It's an outlier. An outlier could be to the extreme left, or it can be to the extreme right. You start paying attention, you'll hear that word outlier used. And again, it's something out of the norm. All right? It's an outlier. It doesn't fit the norm. For example, if Hayden could dunk a basketball, that would be an outlier. For one, somebody his age usually can't dunk, and definitely somebody his size usually can't dunk. That would be an outlier. That would be outside statistical data for somebody his size and his age. Okay, an outlier. Okay? And so you'll hear that term now, and now you know what it means, something that doesn't fit the statistical data. All right, let's go through and give you some more terminology here. So again, a quartile, it's any of 3 values that divide the data into quarters. And again, we did the Q sub 1, Q sub 2, Q sub 3. Again, some like to do a Q sub 4, but technically it's the 3 inner values. The lower end of the box, the median, and the right-hand side of the box. Q sub 1, the lower quartile, is, believe it or not, you go back here, we'll use this one. You agree that, let me go a little higher here, this is Q sub 1 right there, right? This line right there. Well, here's the point that we're going to make right now. Don't do this in your notes. If you look at from the median to the lower extreme, Q sub 1 is actually the median of the lower half of the data. Q sub 1 is the median of the lower half of the data. Therefore, Q sub 3, the upper quartile, is the median of the upper half of the data. That's the way that works. Q sub 3 is the median of the upper half of the data. Earth to daydreamers, man. You guys, come on. It's Box and Whisker Plots. Wake up. Get rolling here. And then, of course, as I've already said, Q sub 2, the second quartile, is the median of all of the data. It's the median of all of the data. All right, so let's go back in and fill in the examples here. And we're saying, what is Q sub 1 for example 1? And you would give a value of what? So look at example 1 on your page, because it's not on the screen right now. Q sub 1 is what value? Say it if you know it. 70. And Q sub 3 is what value? 85. And Q sub 2 is 80. All right, and that's the way that works. Those should be pretty easy questions to do. Now, for some reason, students struggle with little b here. It's a term, it's called the interquartile range. The interquartile range. And I'm going to put an asterisk by it because for some reason, students can't remember what in the world the interquartile range is. It's the range of the box. That's all it is, the range of the box. But I guarantee you, out of all the questions about box and whisker plots, this is the one that you guys will miss the most. And I don't know why, it's so easy. So this time we're going to use example 2. And how do you get the range of the box? All you got to do is take Q sub 3, 45, and subtract from it Q sub 1, 35. It's the range of the box. The box goes from 35 to 45. What's the range? 10, right? And it's 10. So again, if you were going to use the formula, you'd use 45 minus 35. But again, what's the range of the box? It's a 10. It's the interquartile range. If we looked at the first example, what's the range of the box? What's the range of the box, folks? What's the range of the box? 15. It goes from a 70 to an 85. That's 15. What's 85 minus 70? 15. Goes from a 70 to an 85. 15. Range. Okay. So what is the interquartile range? It's the range of the box. And then as I mentioned a moment ago, an outlier is data that lies outside the normal. Outlier. Some students are outliers. They lie outside the norm. All right, don't be an outlier. Don't be a liar at all. Definitely don't be an outlier. Okay, let me help you to know how to make a box and whisker plot. Or again, some say plot, some say diagram. Okay, to help you along, here's the order in which you ought to do things. First, find the median. Now, I will help you guys understand one thing. Notice that the data is in order, correct? You want your data in order, lowest to highest. Now we need to find the median. Now remember, it's different whether you have odd amount of data or even amount of data. So let's figure out how many pieces of data we have. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pieces of data, yes? So how do I find the median? I have to average the middle 2, yes? So you can do this in your head, but those of you that can't, I'll write it. 22 plus 24 divided by 2 is a 22 plus 24 divided by 2 is a, boy, you guys are scaring me. All right, 23. So we now have Q sub 2, and it's right there. It's the line of our box, right, to 23. And here, I'll write it up here as well. Next, find Q sub 3, the median of the data to the right of Q sub 2. I'm sorry, B. Now find Q of 1, the median of the left-hand piece of data, and then Q sub 3, the median of the right hand. Let's do the Q sub 1 first. Take your green and box in the left half of the data. Okay, can you find the median of an 11, a 14, a 15, and a 22? If you know what you're doing, you could do that in your head. If you don't, go ahead and use your calculator. Anybody got the value for me? Nia? 14 and a half, because you're averaging a 14 and a 15. And what's the average of a 14 and a 15? It's a 14.5. All right, so you go on your scale. Now to help me out, I'm going to put a line for a 15, right? And therefore 14.5 is halfway between the 14 and the 15. That's going to help me to get Q sub 1 in the right place. Did everybody follow that? So I took the lower half of data and I found the median. And because my scale was by 2s, I drew the line for the 15 and I did the half, so I know exactly where to put that whisker. All right, so to do Q sub 3, again, do the median of the upper half of data, right? And this one, again, is pretty easy if you know averages. What does a 25 and a 27 average to? 26. Now, again, technically, it's 25 plus 27 divided by 2, but I would think most of you guys can do in your head that that's going to be a 26. All right, so this was 14.5. This was 26. Okay, that one's right on the line right there. And now we can make the box, right? We have the left-hand side of the box. We have the right-hand side of the box. And we already have the line in the box. That's all done. So there's my box. Now all we got to do is do the whiskers. Where do you get the whiskers from? The lowest piece of data is an 11. Again, some use dots and some use lines. I like lines, but you can use a dot as well. So there's the 11. And remember then you take a line from the middle of it to the left-hand side of the box. And what's our highest piece of data? It's a 30. And again, you draw the line to it, and there's your box and whisker plot. Okay, there's your box and whisker plot. Now, that was with an even amount of data. What if there's an odd amount of data? Things change a little bit. So let's look at the second example. Daniel, do you have a question?
Yeah, how did you get 11 and 30?
How did I get what?
11 and 30.
Remember, the left whisker is the lowest piece of data, and the right whisker is the highest piece of data. Okay? Any other questions on that one? Okay, got to ask. Good, I'm glad you asked, because you got to ask if you don't know. Okay, this second situation, here's your data. And this time we have an odd amount of data, so it's a little bit different. Now, if you're going to make a box and whisker plot, somebody raise your hand and tell me, what do we need to do first? What do we need to do first? Juliana? You got it. Good. You got to put the data in order. If you don't, you're going to make a mistake. Now, look, you can put your data in order any way you want, but I do little check marks because I want to make sure I get track of all of my data. 56, 58, 60, 63, 74, 84, 86, 89, and 94. Look, by checking them off, it helps me to keep them in order too, and it also helps me make sure I didn't forget any piece of data. Is it possible to have the same number of data more than once? Yes, because the mode could be more than one time. Well, again, by checking, it'll just help you. It's a little itty bitty thing that some of you guys won't do. And when you go to make your box and whisker plot, you'll forget a piece of data and you'll get it wrong. And that's silly. Just check it off. All right, now on this one, now that we have our data in order, what's the next thing we're after? What do we want next? What do we want next, Nia? We want the middle number. We want the median. So that should be easy for you guys. Can you find the median? I always count how many pieces of data I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, class, what is the median? It is the 74. That's the middle piece of data. When I have an odd piece of data, I box it in. That's my median, Q sub 2, and I'm going to put that. Now this one, we're doing the box and whisker above the number line. The first one, we did it below. This one, we're doing above. All right. That's a little bit off, but again, it's hard writing. Oh, there we go. I'll just move the whole thing. It's hard writing on this electronic pad. There we go. It's one way to move it. Beautiful. Okay. Now, here's the difference. When you had an even amount of data, everybody look at the screen. It's really important. And if you don't listen now, you're going to mess these up. In the first one, with an even amount of data, we went the amount of data on the left. So this had 8 pieces of data. So we found the median of the 4 on the left and the 4 to the right. If we had 20 pieces of data, we do the 10 on the left and 10 on the right to get the median of the lower half, median of the upper half. However, because we have an odd amount of data, we don't include the median, and we do the 4 pieces of data to the left and the 4 pieces of data to the right to come up with the median of the lower half, median of the upper half. All right, you should be able to finish the whole box and whisker plot from there. That's what I want you to do. Now I'm going to pause the video. All right, median of the lower half is a 59. All right, be careful now. That's a 60. So that's the 59. Be careful, because my number line is by 2, so be careful. The median here is 57.5. Again, you would average an 86 and an 89. So 87.5. So 86. This is 88. This is 87. So 87.5 is halfway between and right there. Wow, that's a big box. But it is the box. That means most of the data is in the middle. This is what a test normally would look like. Test data. All right, and what's my lower extreme is 56. I'll use the dot this time. Can use a line. That went a little fast because I'm an electronic pen. And my highest piece of data is a 94. And that's there. And there you go. Any questions on that, anybody? Any questions? Don't pack up yet. We've got more to do. Not going to write any more notes, but we got a little bit more to do. Aaron.
Is it better if the box is on the top or the bottom?
What do you mean if the box is on the top or the bottom?
The diagram.
Well, I gave you the 2 lines to help you to draw a nice looking box and stuff. If I give that to you on a quiz or test, just use the lines I provide to make the box look nice. Okay? But no, and the reason I did it both ways is some people like their box and whiskers to be above the lines of the number line, and others like them below the number line. I just want you to be prepared for both possibilities. Okay? All right, we are going to do some interactive box and whisker plots. So I want you to watch on the board. Okay, so we got some questions here. I'll read the questions for you. Oh, Bloomington High School Orchestra teacher, Mr. Garnett, asked the students in the violin section how many minutes they practiced each day. This box and whisker plot shows the results. So again, it's broken up into quarters. Daily time spent practicing violin. What is the maximum value? How many minutes? Raph. 55, do you agree? You got to be able to read the scale. Can you read the scale? Well, I hope you can. Look, from here to here is 10. So this middle line must be 5. So 40, 45, 50. Raph says 55. We'll submit it. Good work. All right. And it's showing the breakdown here of the situation. All right. What percent of the students study for 50 minutes or less? Don't say anything yet. 50 minutes or less each evening. What percent of students study for 50 minutes or less each evening? Who wants to give me that answer? Kristen.
100%.
She says 100%. You think she's right? 100%, right? Again, that was the high number. So 100% are going to be there. All right, let's go to the next one. Which class? Now we have 2 box and whisker plots. Class 1 is the top, right? Class 2 is the bottom. See that? Class 1, Class 2. Which class has a higher median? Don't say anything yet. Which class has a higher median? Edward?
Class 2.
How many agree with Edward, Class 2? Remember, here's the median of Class 1, it's 50. Here's the median of Class 2, it's 55. Surely it should be Class 2. And it is. Now we have monthly phone usage. What is the value of the upper, be careful, quartile? What is the value of the upper quartile? Colby? How many agree with Colby? The upper quartile is 600. Well, you didn't quite sink in your brain, because this is new to you, what we said, but he is right. The upper quartile. Right here, Q1 is the lower quartile, Q2 is the median, Q sub 3 is the upper quartile, and it is 600 minutes. What percent of the families spent $280 or more on electricity in August? And the box and whisker plot is August electric bill. What percent spent more, $280 or more, on electricity in August? Amber?
25%.
How many agree with Amber? It is 25%. Well, here's our 280. So 280 or more, remember, the box and whisker breaks up everything into quarters. That's one of the quarters. 25% would be a correct answer. Which reservoir has a maximum value that is lower? The Campbell Reservoir on top or the Springdale Reservoir on the bottom? Read the question now. Which reservoir has a maximum value that is lower? Luke? He's going with Campbell, the top one. Who agrees? Well, Campbell's max is 75. And Springdale's max is 85. And 75 is definitely lower than 85. And that's why Luke is correct. Which dealership has a lower quartile that is lower? Which dealership has a lower quartile that is lower? Ashley? Okay, Lee's Auto Warehouse. She's saying Lee's Auto Warehouse has a lower quartile that is lower. How many agree it's Lee's? Because, yeah, the lower quartile is right here. It's 12. And Kelly's is 14, and so that's why she is correct. What is the value of the upper quartile? What is the value of the upper quartile, Brendan?
70.
How many agree with Brendan? It's 70. You'd be right here, right? And so that's why he is correct. What percent of the households recycled between 160 and 200 pounds of waste each month? How many recycle between 160 and 200? Aaron?
50%.
How many agree with Aaron? It's 50%, right? So it's this half. So 25 and 25 would be 50%, and that's why she's correct. What's the maximum value? Don't pack up yet. You'll have pack up time in a minute. What's the maximum value? Allison? How many agree with Allison? It's 20 cars. It is the max, right? The upper extreme. What percent of the trick-or-treaters got fewer than 30 pieces of chocolate? What percent got fewer than 30? I'm trying to get people that haven't gone yet. Emily? How many agree with Emily? 75% got fewer than 30. Uh-oh, no one's agreeing. Somebody have something else? Omar, what do you got? How many agree with Omar? 0%. It's right. 0% lower than 30. There's nobody lower than 30. So it would be 0%. Which class had a higher median? Which class had a higher median? Claire's class or Mia's class? I'm looking for people I haven't gotten to yet. Hayden? Clara's has a higher median. How many agree? Clara's has a higher median. Yeah, her median is 50 and Mia's is 30, and that's why Hayden is correct. What percent of family members are 62 inches tall or taller? What percent are 62 inches taller or taller? Last one. Daniel?
75%.
Do you agree? You should. It's 75%. All right, I got a worksheet for you. Nice thing is, you don't have to write the original problems. Make nice box and whisker plots, fill in the blanks, and maybe next one. Remember, anytime you do an average, I want to see the number divided by ln, however many, right? Just fill in your blanks. Show me how you get your averages. Other than that, there's not a ton of work. Answer your questions. Draw some box and whisker plots. Make sure if your data's not in order, you rearrange your data, right? You've got to put that data in order. All right, you can pack up if you'd like.